Hey everybody, hope you're having a great day. This is Miss Acton. We're going to go over 8.3 notes talking about overlapping and mutually exclusive events having to do with probability. Alright, so sometimes you need to calculate the probability of more than one thing occurring at the same time, and that would be the compound event. Alright, this first term in the vocabulary section at the top that we're talking about, usually it's indicated by using the word and or the word or. So the probability of this and that happening, or the probability of this or that happening. So that's how you can kind of tell that you need to consider whether or not events are mutually exclusive or overlapping. Mutually exclusive events cannot occur at the same time, and they have no common outcomes. All right, and overlapping events have at least one common outcome, and you have to determine if they can happen at the same time. That's when they're overlapping. So in our first set of examples, we're just going to determine if these events are mutually exclusive or overlapping. Number one, has ridden a roller coaster, has ridden a Ferris wheel. Well, you could ride a roller coaster and ride a Ferris wheel. And so, wow, these are overlapping. The fact that you can do both at the same time means you could be in the overlap of your Venn diagram where you have ridden a roller coaster and a Ferris wheel. Rolling an odd number on a die, rolling an even number. Well, those are mutually exclusive because I cannot roll an odd number and an even number at the same exact time. Go ahead and pause the video, try and identify 3, 4, and 5 as mutually exclusive or overlapping, and then unpause the video to check your answers. You should have gotten overlapping for number 3. A person has brown hair, has brown eyes. You can have both of those things at the same time. Number 4, the correct answer is chosen. The answer A is chosen. That can happen at the same time if answer A is the correct answer. A student is a senior and a student is a junior. It's mutually exclusive because you cannot do both of those things at the same time. Okay, so what if you have compound events that are either overlapping or mutually exclusive and you need to calculate the probability of them happening? Well, first you need to identify the probability of each event occurring and the probability of them happening at the same time. And then you use this formula. If the word or, the probability of A or B, you need to find the probability of one, add it to the probability of the other, and then subtract all the ones that have been counted twice, basically. Okay, so we're going to go through some examples, and I think this will make quite a bit of sense. All right, so overall, I want to find the probability in number 1 of spinning a red or a multiple of 3 on this spinning wheel here. With the word or, I know that I need to use the formula above. Oops, that's a highlighter, okay? So the first thing I want to do is find the probability of my first event, red. All right, so how many red pie pieces do I have? I have 4 out of 8. The formula says then I add the probability of my second event, which is spinning a multiple of 3. Well, the multiples of 3 that I have are 3 and 6. That would be 2 out of 8. How many of the 3 and the 6s that I circled are also red that I counted before? Well, one of them overlaps. Okay, so I need to subtract the one that I already counted. So my final answer for this would be 5 out of 8. 5 out of 8 times I will expect to spin a red or a multiple of 3. Go ahead and pause the video, do numbers 2 and 3 on your own, and then we'll start back from there. All right, for number 2, you should have gotten 6/8, which simplifies to 3/4. If you did not get that answer, go check the answer key for the written out work and then see where you might have went wrong. For number 3, you should have gotten 2/8, which simplifies to 1/4. Number 4 and number 5, I wrote the perfect squares and prime numbers down at the bottom. Okay, and you should be able to calculate the probability of each of those events occurring. Now, one thing I did not talk about in 1, 2, or 3 that we might want to talk about is sometimes these events are mutually exclusive, which means in the section where you have to subtract the probability of A and B occurring at the same time. If they're mutually exclusive, they don't have any shared outcomes, meaning you would be subtracting 0. Okay, so I'll show you what I mean by that. You should have done this in numbers 2 and 3. And number 4, all right, perfect square, probability of a perfect square. Well, there's a 1 and a 4, so I have 2 out of 8, plus prime numbers, which if you can see down below, the prime numbers down there, and I'm going to highlight in a different color. I've got 2, I've got 3, 5, and 7 on here, which would be 4 out of 8. Now, do any of those have shared outcomes? No, I did not circle any of those twice. The ones that are blue were not circled again in green. So these are mutually exclusive, and I would subtract 0 out of 8 because they have no shared outcomes. The probability of prime and perfect square does not happen together. So you should get there 6 out of 8 or 3/4 chance of spinning a perfect square or a prime number. Go ahead and pause the video, do number 5 on your own. These are overlapping because there is 1 out of the 8 tiles that is red and a perfect square at the same time, so you should have gotten 5/8 for your answer. All right, moving on down the page. I've kind of already set up and wrote my formula so that I don't have to keep going back to the other page. I wrote it at the top, and then for each problem, I've kind of changed out A and B for the different things that we're working with. Okay, so in number 6, you have a fridge that contains 13 bottles of a sports drink, 5 are lemon lime, 4 orange juice, and 4 fruit punch. You randomly grab a sports drink. What is the probability it's lemon lime or orange? So because it says or, I use the probability of one or the other formula right here, and I wrote it out. The probability of lemon lime plus the probability of orange minus the probability of lemon lime and orange at the same time. All right, so I should be able to find that I would have a 5 out of 13 chance of lemon lime, and then I have a 4 out of 13 chance for orange, and then I subtract 0 out of 13 because there's no way I have a lemon lime and orange at the same time, and so there is a 9 out of 13 chance that I will select lemon lime or orange if I just blindly chose someone out of the fridge. Now number 7, there are 6 orange marbles numbered 1 to 6. And the jar also has green marbles labeled 1 to 3. You can see out to the left side that I wrote all of my different outcomes and the colors because I like to kind of visualize. All right, I randomly pick a marble. What's the probability it is green or has a number less than 5? And so I wrote probability of G or less than 5 to calculate. And I need to use the same formula. I just interchange A and B for green and less than 5. All right, so the probability of it being green, there are 3 out of 9 that are green, plus I have 6 total that are less than 5, so I'd add plus 6/9. But of those that are less than 5, I had already counted these 3 green. And so those 3 overlapping of the 9ths need to be subtracted, because I can only draw a green marble with a number on it that's less than 5. And so my answer ends up being 3/9, which simplifies to 1/3. All right, number 8 deals with percentages, but it's still basically the same, okay? So, a group of senior citizens have won free vacation packages. You can vacation to Bermuda. It's chosen 25% of them. 60% choose Alaska, 15% choose Costa Rica. What's the probability that one randomly chosen senior citizen chooses to vacation in Bermuda or Costa Rica? Okay, so the probability of Bermuda is my first event, 25%, plus the probability of 15% minus the probability of them choosing Bermuda and Costa Rica. Well, it doesn't say anything about this, and they can only choose one vacation at a time, and so I'm going to subtract 0% because you can't choose Bermuda and Costa Rica at the same time. When I combine all of this together, there's a 40% chance that a senior citizen will choose Bermuda or Costa Rica to vacation to. Go ahead and pause the video, do number 9, and then check your answer. I'm going to fill it in real quick for you so you can double check yourself. There is a 95% chance that people can swim or whistle. One or the other or both. Now number 10 is asking us to calculate the probability of someone carrying a backpack and a wallet. All right, and so I need to make sure that I'm solving for this last piece of the formula here, because that's the portion that represents someone doing both at the same time. And I'm going to work backwards using the probability of one or the other formula. Okay, so there are 60% of people that do one or the other, because it says carries a backpack or a wallet. 40% carry a backpack, and 30% carry a wallet. So my equation, it's just like an equation, almost like this piece right here is like an x or a variable that I'm trying to solve for. I have 60% is equal to, combine everything I can, 70% minus the probability of them carrying a backpack and a wallet at the same time. Well, in order for the right side to equal the left, I would have to have that the probability of carrying a backpack and a wallet is 10%, because that would be 70 minus 10 would equal 60%. Okay, find the probability of picking a female or a person from Florida out of the committee members in number 11. If you notice out to the right, I have added all my columns and all of my rows up. In total, there are 31 people represented total in this scenario. So that's why my denominator is 31. Now, what's the probability of picking a female or a person from Florida? All right, so I need to take the probability of choosing a female. There's a 21 out of the 31 total, plus the probability of selecting someone from Florida, which happens to be 12 out of 31. And I might highlight, all right, I've used this row or a column in this row. All right, now I have to subtract anyone that has been counted twice, all the females that are also in Florida at the same time. If you've noticed, I highlighted this 8 twice. Once when I was highlighting the column for females, once when I was highlighting the rows for Florida. And so I need to subtract 8 where they overlap. And so there is a 25 out of 31 chance. Hope you guys enjoyed the notes. If you have questions, text your teacher on Remind or email them. All right. Tomorrow we're going to work on practice having to do with these types of scenarios and calculating the probability of compound events. And so hopefully this has been a helpful intro.